Welcome to ClickMyProject.com. Now we will discuss about enhancing security and privacy for identity-based batch verification scheme in VANET. A clock ad-hoc network can significantly improve the traffic safety and efficiency. The basic idea is to allow the vehicles to send traffic information to roadside units or other vehicles. The vehicles have to be prevented from some attack on the privacy and misuse of the private data. For this reason, the security and privacy preservation issues important prerequisite for VANET. The identity-based batch verification scheme newly proposed to make VANET more secure and efficient for practical use. In this paper, we point out that the current IBV scheme exists on some security risks. It introduces an improved scheme that can satisfy the security and privacy desired by vehicles. The proposed IBV scheme provides the provable security in random model. In addition, the batch verification of proposed scheme is only a small considerable number of pairing and point multiplication computation independent of number of messages. We show the efficiency merits of proposed scheme through performance evaluation in terms of computation delay and transmission overhead. Moreover, extensive simulation is conducted to verify the efficiency and applicability of proposed scheme in real world road environment and vehicular traffic. The basic application of VANET is on-board unit periodically broadcast information on the present states to other nearby vehicles and RSA. For example, traffic events could be accident location, red light warning, change traffic warning, emergency vehicle warning, etc. The security of message exchange play a key role in VANET applications. For example, the information from onboard unit has identity authenticated and integrity checked before it can be laid out. Otherwise, an adversary can replace the information or even impersonate other vehicles to broadcast a wrong information. The wrong information possibly makes some bad situation. For instance, the information of wrong traffic flow may cause the traffic control center to make wrong decisions. Traffic light on heavy side always stay red and other side stays green. In addition, adversary may portray the ambulance to regular traffic light may cooperate with that and violate the driving right of other users. Let us see the flow of our process. First of all, we have to create the initial nodes. For example, we have to enter the number of nodes. After that, we have to select the initial nodes to communicate. Then we have evaluate the intermediate nodes. Then we have create the digital signature for nodes for authentication with onboard unit. First of all, we have to create some digital signature for some vehicle nodes. After that, we have to create some dummy signature for fraud vehicle nodes. Then we have inject the digital and dummy signature on onboard unit for authentication. The onboard unit identifying the dummy signature and detect the fraud vehicle node. Now let us see the demo of our process. First of all, we have to run homepage.java. First of all, we have to create number of vehicle nodes. You just click on the node formation. We have to enter the number of vehicle nodes. For example, we have entered 20 nodes. The nodes created successfully, and we have to select the source and destination vehicle nodes. These nodes are stored into the database. The nodes are stored into a database. After that, view the details, node details. Total node is 20, source node 1, destination node 15, template nodes 14. Then we have to create the helper nodes. For example, node 2. The helper nodes is created, and insert the helper nodes into the database and view the node properties. After that, we have to evaluate the intermediate nodes. Evaluated successfully and insert into the database. These are the intermediate nodes. That means intermediate vehicle nodes. After that, we have to evaluate the node process. Get the source node, that means the vehicle node 1. The vehicle node 15 is destination node, and we get helper vehicle nodes. We have to select any one of the approach MMS and store it into the database. Details are stored into the database successfully. After that, we have to select the, first of all, we have to share the file from one vehicle to another vehicle node, the source vehicle node to destination vehicle node. First of all, we have to select the file to share. These are the file details. These are the file contents to be shared. After that, we have to perform the signature generation. You just click on the signature generation process. The file signature is generated. After that, we have to click the contact traces. The source node 1, destination node is 15, helper node is helper 1, and the node, the data passes via MMS. The intermediate nodes are. After that, we have to perform the signature file creation. First of all, we have to create the digital signature for all valid vehicle nodes, and we have to create the dummy signature for fraud vehicle nodes. Then we have apply signature to all vehicle nodes. Then we have to click the send signature to the onboard unit. After setting the data, we have enabled the onboard unit. From that onboard unit, the vehicle nodes are communicate to each other. And receive the signature, and getting the list of nodes, and we have to find out the fraud node list from that vehicle nodes. We have getting the fraud node 9 and 2. The onboard unit identifying the fraud vehicle nodes from comparing the signature. That means we have applying the authentication, signature based authentication. Finally, we have getting the traces. Get file and get file contents. And finally, we have comparing the performance evaluation of existing and proposed system, spreading rate and recovery rate. we have getting the execution time between existing and proposed system. Thank you.